Hi, in this video, I'm introducing you to the idea of a form of energy called the potential energy. At this point, you will have learned already of a different form of energy referred to as the kinetic energy. So, potential energy is just another example of mechanical energy. And systems can have both types of energy. Um, yeah. So your goal in this lecture is to understand what is potential energy and begin to be able to imagine how an object or a system of objects can have potential energy and what the system, in a sense, can do with that potential energy. So here's an important sort of first step in describing what is potential energy. Potential energy is associated with forces, but only certain types of forces can have a potential energy. There are forces that absolutely can do work, right? That is, they can apply a force over a displacement, but there is no such thing as a mechanical potential energy associated with that force. But there are forces where there is a potential energy. And some examples of forces where there is potential energy: gravity. And this will be one of the first examples of a potential energy that you're going to learn to calculate. You'll see that there is a formula that looks like m times g times h, and that formula describes a gravitational potential energy. There is also, and this will come up later in the course when we study electricity and magnetism, there is an electric potential energy. And this kind of energy, in fact, is the energy that is stored in batteries. This is the sense in which a battery, right, like a AA battery or a lithium ion battery in your cell phone or in your car, this is the sense in which there is energy stored there. It's stored somehow in actually the separations between electrically charged particles like electrons and protons, and, for example, lithium ions. In gravity, the idea is there is a potential energy associated with things being further or closer to the Earth. That is, we say if something is further away from the Earth, that is, it has a larger height, we're going to say that it has a larger potential energy, a gravitational potential energy. So these are examples of forces where there is a potential energy, and some examples of forces where there is not a potential energy are friction, like if a box slides across a floor, or air resistance, like an object falling under the influence of gravity, but where the speed is moderated by air resistance, right? So those are examples. Actually, there is no potential energy, but it's important to note that these can do work. Okay, so just like gravity and electric forces can do work, friction and air resistance type forces can do work as well, but only some very, there's sort of, it's beyond the scope of this class or this lecture to describe why gravity and electric forces can have potential energies mathematically, but I'm going to try to describe it conceptually next. So why is it that something like gravity can have a potential energy? And why is it that something like friction cannot have a potential energy? So let me tell you what the argument is. So there's a sense in which what potential energy is it's energy associated with forces where you can get the energy back later in a different form. So let me, I messed up and let me edit this. Get the energy back later in a different form. And I put it in quotes because it's kind of like a weird way to say it. But there's a real sense in which this is the right way to think about stuff. So let's go back. Okay. So here's a situation where it makes sense to think in terms of a potential energy. So let's say a person throws a ball up in the air. So this is actually a really neat example. So here's a person, and here is the little ball. And what they're going to do is they're going to use a big force, right? This is the throwing force over a fairly small displacement, right? People can only apply sort of throwing forces, say about 1/2 meter or something. Think of a pitcher pitching a ball, but instead of pitching the ball sideways, towards the catcher in a baseball game, the pitcher throws the ball upwards. So they use the length of their arm to apply a throwing force on the ball. And what that does, what that work does, right? So this is a force over a displacement. This amounts to some work. And this work, what it does is it gives us a ball that's low down with a whole bunch of kinetic energy. For the sake of argument, let's say that this kinetic energy equals 100 joules. So what this energy does, right? Well, I've got the ball, it's moving upwards, and it's got quite a lot of motion energy. So what it does is it travels up and gets to some highest place. And when it gets there, though, the velocity is equal to 0. And what this means is that the kinetic energy is equal to 0, right? So it has no kinetic energy, but what it does have is some height. So this is where the energy is, right? So our system, at the point at which the ball is at the highest place, is exhibiting its energy in the form of potential energy. It's got all 100 joules of energy, but the way it exhibits it as potential, no longer kinetic. Earlier, the ball was exhibiting all of its energy as kinetic, and it had no height. So it had no potential energy, right? So there is a sense in which we can get this energy back later in a different form. So all we got to do, right? This ball is not finished in terms of, the activity of it. It's going to fall back down. And as it does that, it loses its potential energy and regains its kinetic energy. And this is the sense in which we can get the energy back, right? Earlier, we have this form of energy. It's called potential energy. In particular, it's gravitational potential energy. And later, right, a little bit later in time, I don't have potential energy left, but I do have a different form in its place. So in a sense, the energy was stored and we could get it back later. So contrast this with a different situation where we're going to use friction, which is one of the types of forces that I described that you cannot describe potential energy with, because there's no sense in which you're storing up the energy for later use. Although this is not strictly, so let's, later mechanical use. So a car is, let's say I've got a nice big flat horizontal road, and here is a car. So there's wheels of the car, and it's moving, and it's got quite a lot of kinetic energy. And then what it knows it needs to do is it needs to slow down before, say, hitting a house, right? So what it does is it uses its brakes to ask for a force so that it slows the car down. So let's say that braking force is a force backwards, right? So this is the braking force. And you'll notice that as the car puts on the brakes and slows down, it still displaces this way, right? And this is the situation where we're going to get a work done by this friction force that is negative, right? So whenever you use brakes to do friction, what happens is various objects get warmer. And this is where the energy goes. So a little bit later in time, the car will be, say, here, right? It gets to here, and it has no more kinetic energy because it was able to stop, right? The velocity is equal to 0, which was the goal of using the brakes. So it does not hit this house. I'm not going to redraw the house. But interestingly, what has happened is you've warmed up the car, right? So the brake rotors are warm. And not only that, but there's a real sense in which you warmed up the road, right? You made the road warmer. Oops. Excuse me. Okay, sorry about that. So the car slows down. So what's interesting is the road's definitely warmer. So let me finish writing this word. So there's warmth in the road, and there's warmth in the brake rotors, and the brake pads and stuff like that. And we no longer have the kinetic energy, but there's no sense in which that energy is stored in such a way that we can get the energy back later, right? So our world, the way the universe works, is it doesn't just suck back in all of this warmth and reconvert that warmth back into kinetic energy, right? I wish it did, because then you would solve lots of problems with the energy shortages in the world. But this is not how the world works. So the truth is you can't store potential energy in friction. If your goal, though, was to create a hot surface where you could do some cooking or, welding or something useful with heating, there is a utility in using friction for warming. When you're cold outside and you rub the palms of your hands together because your hands are cold, you warm up your hands, right? And so there's utility there. But the thing is you have not stored mechanical energy that way. What you've done is you've stored up what's referred to as thermal energy. And thermal energy is not mechanical energy. So this is not potential energy, right? Because I can't get it back as the car being in motion again with kinetic energy. Okay,